Hello, good day viewers. Still on double absolute value inequalities. Today we have another problem, which is the absolute value of 2x minus 1 less than the absolute value of 3x plus 5. Let's start with the first method. In the first method, we are going to find the zeros of these two functions. Let's start with the first one. If you take this one, you set it to be equal to 0, you have 2x minus 1 equal to 0. Take negative 1 to the other side and divide both sides by 2. X will be equal to 1 over 2. And if you set 3x plus 5 equals 0, it implies x equals negative 5 over 3. Let us create three intervals. The first one would be from negative infinity way down to negative 5 over 3, excluding that. Then we have negative 5 over 3 inclusive way down to 1 over 2 exclusive. Then the last interval will be from 1 over 2 up to positive infinity. Next, we are going to test some values of x within these intervals. So what do you think if we should take any value of x between negative infinity down to negative 5 over 3 and plug it into the first function here? All these values are negative, right? So if you replace x with any negative value, the whole of this will be negative. So 2x minus 1 will be negative. So we have negative version of 2x minus 1. What about this one? Let's take a value, for example, we may have negative 3, right? It is within this interval. Negative 3 times 3 is negative 9, and negative 9 plus 5, that will give us negative 4. So it means that this function will be negative as well. We have negative version of 3x plus 5. I think 0 is within this interval, so we can test 0. What happened? If you should plug in 0 here, you have 0 times 2 is 0 minus 1 is negative. So it means that that function 2x minus 1 will be negative here. That is negative 2x minus 1. And since this is part of the values, you can plug it here by multiplying 3 by this. That will give us negative 5, and negative 5 plus 5 is 0. So even if it is 0, we are going to consider it as positive. So we have 3x plus 5 as positive here. Then the last interval, all these values are positive, and one of the values we can test here, I think we can use 2, which is within the interval. 2 times 2, 4, and 4 minus 1 is 3, which is positive. So all other values will satisfy. So we have 2x minus 1. And this one as well, if you should plug in 2 here, 2 times 3 is 6, and 6 plus 5 is 11, which is also positive. We have 3x plus 5. And you can see that the inequality is less than type. So we are going to solve these three inequalities. Let's start with this one. It means that we are going to take this less than this and solve. Let us distribute this negative sign. We have negative 2x, negative 1 times negative is positive 1. This is less than negative times 3x is negative 3x. Negative times positive 5 is negative 5. Then if you take this one to the other side, it becomes positive 3x minus 2x, that is just x, less than, taking this one to the other side, it becomes negative. Negative 1, negative 5 is negative 6. Then you have to look at this value. Is it within the interval? Yes, negative 6 is within the interval. So we move to the next one. If you should distribute this negative sign, you have negative 2x plus 1 less than this one, which is 3x plus 5. 3x plus 5. Take this one to the other side, it becomes negative. Negative 2x, negative 3x is negative 5x. Then you take this one to the other side, it becomes negative. 5 minus 1 is 4. This is less than 4. You divide both sides by negative 5. X is greater than negative 4 over 5. Remember to change the direction of the inequality whenever you divide or multiply both sides by negative value. So is this within the interval? This is negative 0.8. Negative 0.8 is indeed within the interval, right? Because this is negative 1.666. So, which is also less than this value, right? And you can see that this is greater than that value. So that value is within the interval. Then let us take the last one, which is this less than this. 2x minus 1. 2x minus 1 less than 3x plus 5. 3x plus 5. As this crosses over, it becomes negative. So 2x minus 3x is negative x less than. Take this one to the other side, it becomes positive. 5 plus 1 is 6. Divide both sides by negative 1. X is greater than negative 6. So is negative 6 within that interval? No, because all these values are positive. So we are going to discard this solution. We don't want it. So where are our solution? This and this, right? So this is from negative infinity down to negative 6. And this is from negative 5 over 4 down to positive infinity. So let us write the solution here. X belongs to the set of values from negative infinity down to negative 6 union from negative, is it 4 over 5 down to positive infinity. So this is the solution. So now let us take the second approach, which I think is the simplest one. Remember I told you this absolute value of 2x minus 1 can be written as the square root of 2x minus 1 squared, right? Less than the same thing here, the square root of 3x plus 5 all squared. The square root will cancel, which means that 2x minus 1 whole squared is less than 3x plus 5 all squared. You can take this one to the left hand side. We have 2x minus 1 whole squared minus 3x plus 5 whole squared, and this is less than 0. This is nothing but difference of two squares, right? You take this, you add to this, you multiply, you take this, you subtract this. Let's start with the addition. 2 plus 3 is 5x. This plus this will give us positive 4. Then multiplied by what? Now you subtract. 2 minus 3 is negative 1, which is negative x. Minus 1 minus 5 is minus 6. Minus 6 less than 0. Let's find the zeros and graph it. I think it's better than using the number line. So if you set this to be equal to 0, it implies that x will be negative 4 over 5. Set this to be equal to 0, it implies x is what? Equal to negative 6. So if you have x and y axis, all of these are negative. And because the parabola, the leading coefficient, you can see that it is negative. Because if you take this, you multiply by this, that will give us negative 5x squared. So since the leading coefficient is negative, we have an up and down parabola, something like this. And because it is less than type, less than, we are talking about these regions. These x-intercepts are negative 6 and negative 4 over 5. So we are talking about our solution from negative infinity down to negative 6, and from negative 4 over 5 way down to positive infinity. So x belongs to the set of values from negative infinity down to negative 6 union from negative 4 over 5 way down to positive infinity. The same solution, right? But different methods. Thank you for watching. Do share to your learning colleagues, and don't forget to subscribe to my YouTube channel for more exciting videos. Bye bye.